Almost everyone that has worked with JavaScript has heard of the V8 engine, the idea of the JavaScript engine. And most people know that JavaScript is a single-threaded language, that it uses a callback queue. You may also hear phrases like JavaScript is an interpreted language. Let's tackle what that means over the next couple of videos. What is this engine that we speak of? Well, if I write some code, like let's say const is happy equals to true. Well, we just wrote some JavaScript. I'm assigning the true boolean to the variable is happy. Now, how do we read this? Or how does the computer read this? Imagine if somebody comes up to you and gives you a computer and they tell you, hey, tell this computer to display a picture of horses on the screen. And you start looking at this computer and you tell the computer to display an image of a horse or horses in French. Is the computer going to understand you? No, the computer would have no idea what you just said. In similar fashion, if I gave a computer with a CPU a file that is a JavaScript file, and I tell it, hey, read this file and do something for me, well, the computer only understands ones and zeros at the end of the day. And when we give it the JavaScript file, it's like me talking to a computer in French, and the computer being like, what? What are you talking about? Plus, talking to a computer in French, well, people are going to look at you like you're a crazy person. So the computer doesn't really know what JavaScript is. So how are we able to communicate using a JavaScript file so that the computer displays pictures of horses? And this is the first step in our learning, and that is the JavaScript engine. By having a JavaScript engine right over here, it allows you to give this machine the JavaScript file, and this machine is going to understand this file and tell the computer what to do to display pictures of horses. In a sense, you just created a translator, so you can communicate with somebody that doesn't know your language. And this special engine, called the JavaScript engine, understands JavaScript. Our computer finally understands us because of this JavaScript engine, and it says, I'm on it, boss. I'll start displaying those horse pictures. There you go. That's our first step. And over the next couple of videos, we're going to talk about exactly what's happening inside. But do you think there's one JavaScript engine or many JavaScript engines? Well, as you can see from this Wikipedia list, there are a ton of engines. And they're called ECMAScript engines, and we'll get into why that is later. But these are all the JavaScript engines. Some of them you may have heard of, like V8 or SpiderMonkey or Chakra. So anytime we use an engine, we're able to give it a JavaScript file. And this JavaScript file gets understood by the engine, and it allows this engine to communicate and tell the machine, the computer, to do what we ask it to do with JavaScript. Now, these engines are written by programmers. For example, V8 engine is written in C++. But why do people write these engines? 2008 marked a really pivotal moment in history when it comes to JavaScript, because V8 was released by Google. Before then, most browsers used engines that were very basic, which meant that JavaScript was a little bit slow. You see, Google had this problem. They had something called Google Maps. And Google Maps, as you know, requires a lot of power. It does a lot of things. You can ask it for directions to zoom in and zoom out, maybe even use Street View. And all the previous engines before it would make Google Maps very, very slow on the browser. And Google, because they're a search engine, they want everybody to use their search engine. And they built a browser in order for them to control more of the market. So with Google Maps and their own Chrome browser, they said, we're going to write our own JavaScript engine, the V8 engine, so that JavaScript runs way faster on the browser than it's done previously. And in 2008, they released V8. But the big takeaway for us here is that really, really smart people work on these engines so that our JavaScript runs as fast as possible on the browser, on the server, or any type of computer. So every day, JavaScript gets faster and faster for us because of the work that goes into these engines. Okay, but what is inside this engine, this magical machine that understands JavaScript? It reads our code and then it runs this code. Let's get into that in the upcoming video. Bye-bye. Welcome back. So we know that this thing called the JavaScript engine takes our written JavaScript code and does some magic to tell the computer to do what we want it to do. So what's happening inside of this engine? And here's the tricky part. As we know, this engine can be built by anybody. Yes, that means you can build your own JavaScript engine. But it's a lot of work. And at the end of the day, it's just a program. And the V8 engine, which is the most popular, most common, and some would say the fastest JavaScript engine that the Chrome browser and Node.js uses, which we'll talk about later on, this engine is written in C++, a low-level programming language. But let's see what's actually happening inside here. Inside this engine, it looks something like this. We give it a JavaScript file, and first it does something called lexical analysis, which breaks the code into something called tokens to identify their meaning so that we know what the code is trying to do. And these tokens are formed into what we call an AST, that is an abstract syntax tree. So we parse the code, that is, we try and figure out how the text is divided up based on keywords from JavaScript, and it gets formed into this tree-like structure called abstract syntax tree. And there's a fun little tool online that you can use to demo this. If we go to astexplorer.net, it'll show you how this abstract syntax tree looks like. And you have a bit of code here, and as you can see, you can look at it in JSON format, or you can use it the tree. And it breaks down the program into different things that are happening. We have a variable declaration, a declarator, and although this may look like gibberish right now to you, this allows the engine to understand what's going on in the program, or at least break things down one by one. And once in this form, it goes through something called an interpreter, profiler, compiler, and we get some sort of code, which we're going to talk about later on. And this whole engine is going to spit out some code that our CPU on our computers is going to understand to give it instructions. And you can think of this whole process, again, which we're going to talk about in more detail coming up, as something like this. We can create our own JavaScript engine by saying function, and let's say JS engine function, that takes in some code, and this code is going to return for us, let's say code.split, and we'll use some regex here just to split up our code. And now if I write some code here, let's say JS engine, and we give it our code, which will be a string that says variable a equals to 5. Look at that. We've created a simple engine. I know, there's a lot more complexities to it than that. But that's what it's doing. We're giving it a piece of code, which just gets stringified. And then it tries and breaks things down into different parts. So that maybe in this function, we can say, if you see variable keyword, that means whatever comes after it is a variable that we're going to assign, and so on and so forth. But you might see a problem here. What problem or problems do you see with everybody creating their own engines in JavaScript? Just like we did, right? Can't we just create our own engine and all of a sudden, boom, there it is. We have our JavaScript engine? Well, yes, you can definitely do that. But remember our list over here, how it was called ECMAScript engines and not JavaScript engines? That's because if everybody can just create a JavaScript engine, it'll just be total chaos. Which is why ECMAScript was created. It tells people, hey, here's the standard and how you should do things in JavaScript and how it should work. And ECMAScript is the governing body of JavaScript that essentially decides how the language should be standardized. So it tells engine creators, this is how JavaScript should work. But internally, how you build the engine is up to you as long as it conforms to these standards. And if we go back to our example over here, this engine, inside of this box, as long as it conforms to ECMAScript standards, I can do whatever I want as an engine creator. So companies and organizations are battling to have the fastest engine so people use their tool. For example, Google is really interested in having the fastest engine so that more people use their Chrome browsers, so that they use their search engine, so that they can sell more ads and make more revenue. But keep this in mind, that this can be implemented any way we want, and it constantly changes to find the fastest way possible to have JavaScript work in our browsers or even outside of our browsers. And we're going to be talking about the V8 engine here because it is the most popular, and you might see some different variations of this. But what we're going to talk about here applies to most JavaScript engines. And although things may change over time, as long as you understand the principles and why it's built the way it is, we're going to be able to understand how to write optimized code. But before we get into that, let's talk about what these things are. We have the interpreter and the compiler. I'll see you in the next video. Bye-bye.